Greetings. My name is Dr. Ronelus. I'm sitting here with a former scholar of mine. This is Daniel Acosta. Today's our first session in a work that I want to, share with the world, for lack of a better word. Let me first give a little bit of background history as to who I am and who Daniel is, and then we can proceed from there. I've been teaching with the New York City Board of Education since 1999, and I can recall the first time I walked in a classroom learning environment at PS 33 in the Bronx, and the principal asked me, "What can you do for us here?" And I told her, at the time this was Dr. Lopez, and I told her that I am here to raise a few geniuses. And from that time on forward, I've been pushing to see what education is, and in terms of science, where education can go. Now, I can recall an experience I've had with this young man here. In kindergarten, I remember his teacher at the time was Mr. Rollman. And he came to me once. He said, at the time I was Mr. Ronelus, he said, "Mr. Ronelus, I have a student in my kindergarten class. His name is Daniel. I would like you to meet him." He said, "You really got to meet this guy." So I said, "Okay, sure." But for some strange reason, I just kept buying time. And one time he came back and asked me, "You got to meet this guy." And I remember walking in the annex here, and when he introduced me to Daniel, the first question Daniel asked me was on Einstein relativity and space-time travel. And I was just blown away. At that very moment, I realized right away that I was in the presence of someone beyond elementary school learning. And at the time, I said to myself, you know what? I need to talk to this kid and figure out who he is and what he represents. Now I'm going to speed walk into third grade. In third grade, I had this computer here open, and I projected this image on a smart board. And Daniel asked me, he said, "Mr. Ronelus," at the time, "can you explain to me what these things are?" And I said, "These?" I laughed. I said, "This is all Maxwell's equations." He said, and he told me, "Well, I want to learn about them." I said, you sure? You serious?" "Of course." So I went home, and I had a book on Einstein theory of relativity at the time, a kids-friendly book, and I gave it to him the following day. And he went home and he read it over, and he asked me if I had any other books that I can lend him. And I was just blown away by that. So when I inquired and asked him what did he learn from it, the book I lent him, he said, "Well, it was a pretty good book, but can you have something more substantial?" And from this point on, we've have amazing conversation. We got into Maxwell's work. Then we moved beyond that to understand where science is heading. So, to make a long story short, it's been about, how many years now?
About 4 years.
About 4 years. We've been in touch throughout that time frame. And I find myself today sitting with Daniel so we can have a quick Socratic conversation about what he has done so far in his study and where he see himself in the not too distant future. And if he can at first kind of walk us through that moment in elementary school when he realized that this is what he wants to do. For me, I call it a quantum leap, because you cannot have a kid in a lower elementary grade that somehow just within a year, all of a sudden he was talking about Maxwell's equation, wave theory, black hole, and it just leap that is so far out there that I think that's something that needs to be documented. So, anyway, Daniel, if you can kind of walk us through your experience, that would really be grateful. Introduce yourself.
Well, my name is Daniel, Daniel Acosta, as he mentioned multiple times. And as far as my experience in the physics and the maths, I found it very fun, very entertaining learning these different fields of maths and physics that physics and maths comprise of. Simply because it felt like the same sensation you would have in speaking another language. Because maths is another language that one speaks, and most speak more fluently than others. And surprisingly enough, it was more fluent in my case than it was for the rest. But I didn't really find it to be an aberrational skill. In fact, in the fourth grade, I began to notice, not in third grade, in the fourth grade, I began to notice that I was more, how do you say it? I was more of an erudite in physics and science than anybody else was. I felt like in the third grade, I was like everyone else, like the average person, but it was this sort of inexplicable desire to understand physics and maths that inspired me to further surmise the different fields in physics and mathematics. And where I'm now, well, I'll go through it time-wise. In the fifth grade, I began to, well, in fourth grade, during the summer, I remember I was learning about first spherical trigonometry, and then from spherical trigonometry I moved on to pre-calculus, and after pre-calculus, calculus, and then the courses that one would normally take in either high school or calculus in terms of advanced maths. And then after calculus, I did read some textbooks that were lent by by a student, a former student
Right.
of Mr. Ronelus, and he also gave me material about the biography and also the work, groundbreaking works of other physicists like Norbert Wiener and Roberts and Einstein himself. And after that, I began to become more indulged into calculus, but mostly electromagnetism. I began to digress from electromagnetism because I was, for some reason, very, very interested with the math that one would usually go over. I remember in the fifth grade, I asked my father, could I purchase the textbooks on the courses that one usually takes in college? And he was surprised at first, but and there was an assent. And surprisingly, after 2 days, I completely forgot about what I wanted 2 days ago. He brought me piles of textbooks, and as it were, I was very agog about reading them, and I did read them. Since I was a very affluent reader at the time, and again, it was the same sensation you would get learning another language. It is mostly entertaining, and that's something that I never forgot about maths. It's very entertaining learning about these different fields of mathematics. In any event, incidentally, I went from calculus all the way to vector calculus after I read about ABC, advanced calculus that you would take after Calc 2, that is if you were chosen. and then after vector calculus, I did multi-dimensional calculus, and different kinds of calculuses. I just can't name them off the top of my head. It's just it's lots of research, incredible amounts of research that I've not forgotten, but it's very astounding. And afterwards in the intermediate school, that's when I began to look into different skill sets that I could acquire, like chess, music. In music, I learned the piano by myself and trombone, and I took classes on, and I'm looking forward to learning trombone once again, since I've forgotten. Generally other skills that one would usually look into when they're in the intermediate school or high school. Again, it was until the 6th grade that I felt like I was average like everyone else, except I didn't forget about the astounding research that I did in the prior years. Ensuing 6th grade and 7th grade, that's when I finally contacted Mr. Ronelus, because it's been a while since I didn't talk to him, and for some reason when I messaged him, I used to think, since I haven't messaged anyone through email in a while, I used to think that because of the astounding research that I did, I had to write in code. But not code in the sense that one would when they're writing in Python or C++ or any of such kinds of code, but in the mathematical sense. So I used to write about esoteric research I've been doing ever since in a very odd language, and he contacted me, and he told me that he was very proud of my research, and that we were going to talk to each other once again, but we never managed to, because I had lots of things, again the skills that I acquired and I wanted to improve upon during 7th grade and 8th grade. But I still occasionally messaged him about the research that I've been doing, besides the skills that I've acquired in the preceding years. And then in the 9th grade, in this case real time, or before this presentation, I've been doing I was doing more research on quantum mechanics and group theory than I have in the intermediate school, and mostly Hamiltonian physics, because that goes beyond the Lagrangian physics, and quantum field theory, and quantum field theory goes past the quantum theory, which is what I was been going over the 8th grade, and mostly modern physics that I was studying, and then one day we came across, Mr. Ronelus remarked, well, why don't we go over the bleeding edge of science, what's going on in science in real time, and I was interested. I commented, and I said, why not, and I'll get back to you. I'll do some research on some of the unsolved problems that were available in the field of physics and mathematics, and I was doing some research, and I came across multiple unsolved problems. Some of the unsolved problems were proffered by some university, I forgot where, and one of the problems that were proffered was the YangMills Theory, and the YangMills Theory is a question of unifying the electromagnetic field with different kinds of forces, and these different kinds of forces unified with the electromagnetic field, when unified, would hold theoretically using using they're using Gaussian mechanics or different kind of mechanics that were brung up by famous physicists like Feynman, who contributed significantly to quantum mechanics. And I read that there was one problem that we still could not solve, and is still yet to be solved, which is that in unifying these two fields, there would be it would require a lot of energy to unify these two fields, and that it was required that there should be that if these two fields were to be unified, there will be no mass as an outcome, and in order for the unification or the grand unification theory to work, there had to be some kind of presence of mass that low energy ranges, and the reason why that's so difficult is because in the field of quantum mechanics, it's very arduous to quantize these different fields, and it's so difficult to pinpoint these different ghost particles, these different aspects of unifying these fields at very low energy ranges, and so instead we have to put it in a schematic, very complex schematic that still abides by Gauss's theory, but also we have to incorporate some computer science in order to evaluate how we can unify these two fields at low energy range.
Well, you've heard where we are right now, and as Daniel has just stated, me keeping in touch with Daniel has always been an issue of, I look at it this way, when Maxwell stepped on the scene and to vindicated Faraday with the field concept in physics, at the time, the idea of a field was something that was revolutionary, of course, but yet, although Faraday was ridiculed, Maxwell himself could not have resolved these issues until he abandoned the traditional way of looking at the nature of reality, in which, after his first attempt at understanding the field, which is on Faraday's line of force, then we had the second attempt, which happened as a result of the spinning model. But what I find interesting is on Maxwell's third and masterful work on a dynamical theory of the electromagnetic field, and that requires a fresh approach as to how nature behaves and the nature of reality. So even a genius such as Lord Kelvin, as we all know through the histories, he just couldn't understand this new approach. And the idea is sometimes you have to go beyond what's already established. And looking at the history of science and physics in particular, any sorts of advancement that has ever been made, you always have an anomaly, something that just doesn't add up. Then that becomes the structure for the scientific revolution. So looking at these new sets of problems that we don't have an answer for in physics, like Daniel mentioned the YangMills Theory and the gap problem, which is currently open right now. I've been thinking a lot about a new way of looking at nature. I don't have an answer to it, but what I do know is somewhere along the line we have to go beyond field theory, and I'm sure a lot of physicists who are at the bleeding edge of where physics is heading, that's what they know must happen. But the question becomes, how do you even progress and move in this new terrain, uncharted terrain? The idea with Daniel is for somehow to poke his brain, in a sense, to look at what's currently at the bleeding edge. Like right now, as we all know that I'm sure Einstein is rejoicing in his grave to know that after so many years, gravity wave has finally been detected. Okay, so this is a whole new approach now, again, in physics, and a lot of questions that we were not able to answer, as you all know, we will be able to at least able to make sense of. But then again, I look at it this way. I always share this with Daniel. What Einstein has done is based on the work of Maxwell, as we all know. So, but what's the next big question beyond the field theory? And this is where we are right now, and we are looking at this thing using another angle, okay, and looking at all that has been done before, where science is, where physics is, and the idea of beyond the field theory. So with Daniel, I'm trying to look at the problem from this perspective. Maxwell looked at it at nature in his third masterpiece on dynamics. Okay, and he stated, as we all know, that nature can keep its secrets as long as it obeys the laws of dynamics. So we may never be able to understand the secrets of nature, and I'm sure nature probably will never reveal its secrets. But an approach has to be taken that is so different from what has been done before, just like Maxwell had to look at the science of dynamics to carry out this activity. Therefore, this is where we also have to think in order to move physics, I think, beyond where we are right now. And the question is, well, what do you look beyond dynamics? And what is that new approach is going to be? I don't know what it is. But what I do know is a lot of questions in physics that we don't even know yet. In order for those questions to even be entertained, somehow along the line, we're going to have to move beyond dynamics. And this is where we are right now, and that's the idea we plan to develop as we proceed. Yeah. So Daniel, quick question for you. Looking at everything you've studied, in terms of like where physics is right now, do you have any idea of how you think you might be able to proceed? I mean, what is a big question for you right now that you would like to see physicists working on right now?
Well, again, I feel like we should. We shouldn't really represent. We shouldn't really represent how, like you said, the mechanics of nature. We were once discussing that before we were ever recording the physics of nature as a schematic, but instead simply to understand nature as it is, but still utilize what we know in order to ultimately understand the mechanics of nature. For instance, what we know about topology and this association with group theory, and how we can use how we can use the notion of dimensionality as a promulgation of these dimensionalities in the topological sense to ultimately reach another end in the in the vicinity of finding a new approach to where we are right now, which is or where we physicists are right now, which is future.
Well, this is going to be our first session. There are a lot of questions that we could discuss here, points, but the gist of this small session is to just kind of give everyone a background in terms of the Alchemist Club, what we've done here since 1999 at PS33X in the Bronx, and also to kind of show as educators that for me personally, the idea of a zone of proximal development where you somehow have a student learning and the kids reach a point where they are comfortable with the knowledge that they have, but you can push them a little bit to some uncomfortable quasi information they might not be privy to, but they can learn it. What I'm saying here is totally something different. What I'm saying is I don't look at this thing as any zone. For me, there is no barrier or boundary as to what that is. And Daniel is a perfect example of a kid, a scholar, a scientist that from the very beginning in the early elementary grades, by the time he reached 4th grade, as you heard from him, there was this sense of freedom to just take a quantum leap, for lack of a better word. And this is what we're trying to address here. And for me personally, I think it's not a question of Daniel. This is a question of what education has to become, where we no longer create the system of compartmentalized knowledge or believing that a student can learn this amount of information, and especially in this day and age, and in this digital universe that is quickly approaching. This is a new way we think that it can be done, and we have been doing it in the Alchemist Club since 1999, and we just wanted to share these few ideas with you. And that's all we have to say for now. So Daniel, it's a pleasure to see you today, and we will continue this conversation again as we proceed. Thank you.